do all of that would help greatly as we are about to commence the webinar.
Push down. Can you move the cursor back over here and click on that? She's got it.
Thank you everyone for joining us. For those who have just come on board, please complete your name and details in the log-on box. For those who have just done that, thank you very much. Welcome to the second in our series of IPWEA's SLSC program. The first was conducted about 2 weeks ago on the roadmap, and this is the second of a series of 3. This particular webinar addresses the current situation of the draft model LED public lighting specification. This would not have been possible without the assistance of the Australian Government, Department of Environment and Energy, and the E3 Equipment Energy and Efficiency Committee. The E3 Committee draws together all the states and territories of Australia as well as New Zealand, and has been the driving force working with IPWEA and SLSC in promoting these changes to regulation and direction to accelerate the rollout of LEDs and smart controls. So I'd like to publicly thank the support of the federal government. We have almost a full capacity on board on the webinar, just on 100 people, and for that I'd like to say thank you for your time. The webinar will take 45 to 50 minutes depending on questions, and will allow you to have input into this process of consultation for the model specification for lighting. We couldn't have achieved this under the SLSC program if it wasn't for the support of major industry partners, including Philips, Light Source by GE, Gerard Lighting, Silver Spring Networks, Cisco, and our major industry partners for Local Government Association, Energy Networks Australia and Lighting Council Australia. As I said, these organisations form the council, and they form the direction and strategic policy for SLSC program, and they are the guiding direction under which we both are accountable and also respond to in terms of moving the program forward. Supporting the SLSC Council is a very impressive list of technical and advisory group members, our TAGs. These organisations here are the creme de la creme in terms of the technical competence, specialist technical ability they bring to the organisation, and we thank them very much for their support as well. You'll see there a number of councils, and those councils that are listed have been by invitation only, and it's because they have demonstrated a clear experience of either installing or about to install LED and smart controls, and we wish to partner with those councils as champions and industry leaders in the process. As such, other councils will be able to follow much of their lead as we work with the council and with the TAG group in developing up the new programs that we're doing. To move into the specifics of this particular webinar now, I'd like to introduce Graham Mawer. Graham has been one of our 3 key people, together with Brian King and Godfrey Bridger in New Zealand, who have been instrumental in assisting IPWEA and the SLSC program in guiding and directing much of the functioning and the research that's been undertaken in the program. As a team, we've been able to deliver the requirements that the federal government has been looking for and provide the assistance to industry, to DNSPs and to state government by things such as the roadmap, which Graham will talk about in a few moments. So I hope you enjoy the webinar. It is the second in a series of 3, as I've mentioned, and we look forward to your feedback and comments during the process so that we can enable Graham to take us through this current iteration, that the first iteration for the model specification, and look forward to your consultation feedback, and he'll outline the time frame and the process from here. So I'll hand over to Graham and look forward to your input as we go through the next 45-50 minutes. Thanks, Graham.
Thank you very much, Robert, and good morning, everybody, and good afternoon to some of our colleagues in New Zealand. Thank you all for joining us today. Just to put this in context, about 65% of our audience is from local councils, both big and small. There's quite a number of road authorities as well. About 25% of the audience is various suppliers to the industry and service providers, and about 10% other types of organizations. Many of you attended a conference a couple weeks ago in Brisbane organized by the IPWEA, which covered some of the introductory sections of this presentation, which I'll go through fairly quickly, but I'm cognizant that quite a few weren't at that event, and so I just want to give you a bit of context and background first. So we're going to talk today about the model public lighting, LED public lighting specification, its purposes and benefits, and who should use it and for what type of projects, the key elements of the specification, and the key items that we think people are going to be interested in consulting on. So first of all, a bit of context. The IPWEA started its program last year and did a fair amount of consultation with stakeholders across the industry and government and local government, the supply side of the industry, and heard a lot of concerns about the current state of tendering with LEDs. People taking specifications from a variety of locations that were often inconsistent, internally contradictory, and sometimes incoherent, making it very challenging for people to bid on and very challenging to get good outcomes. So this was one of the recurring themes in the early part of the program, and it was therefore highlighted in the roadmap, which was released in December, that releasing a good, robust model specification was one of the top priorities of the SLSC program, and that's why we're at this point that we are now. And it's all about bringing confidence to both buyers and sellers to effectively procure LEDs that are fit for purpose. So we've been undertaking some early consultation with key technical advisors to the program. That's largely complete. And later this week we'll be releasing the model specification to the Council and the TAG, the Technical Advisory Group. And they'll be looking at this through the month of April. And the other specification, which Brian King is going to do a webinar about next Tuesday, the 11th of April. And then we're expecting that these will be released via the SLSC website at the end of May. And if you participated in today's webinar, you'll certainly be on the distribution list for this. Very briefly, what are the benefits of model specifications? Well, it's all about saving you as an end user money, lowering your risks, getting better technical outcomes, and driving more competition in a really robust way that doesn't leave you having to reinvent the wheel, helps you meet all your internal probity requirements. But of course, a model specification isn't useful to you until it's customized to your needs. So you can't simply issue a document. But what we're trying to do in the model specification is give you enough guidance and enough choices. It should be fairly easy to customize it for your needs. Now, there's some very solid international precedent for these types of model specifications with respect to LED lighting. The most notable is probably the U.S. Department of Energy's Municipal Solid State Lighting Consortium. The conversion of their spec was introduced in 2014, and it helped many small towns as well as large cities in the United States robustly tender for LEDs. It's been a great source of information for us and a great reference point. There's a similar program in Canada, Lightsavers, who've issued their own model specification. We've also been looking at that. There's something called the Design Lights Consortium in the United States, And of course, in this part of the world, New Zealand Transport Agency has a very good document called the M30 specification, which is effectively compulsory in New Zealand for all road authorities and is a good source of reference for us. So in terms of the objectives for this model specification, we want to make sure that we help you select the right luminaire for your specific application. You can't just tender for LEDs. Generally, it has to be about your park or road, paying attention to the geometry and the requirements that you have. We're also going to be including an option in the specification to help people do systemic energy performance assessments. This is something that's likely to come out of the standard soon and helps you assess the energy performance of an entire installation, not just the lumens per watt of a particular luminaire, but how much the actual installation will use inclusive of control systems. Now the model specification will cover most typical pedestrian, vehicular, and public area lighting tasks. There's a couple of things it won't cover in its first iteration, and those mostly have to do with flood lighting, but that's certainly an area that can be added in subsequent iterations. And I need to point out that sports field lighting, which I know is a great concern to many local governments, is not covered by this specification. It's covered by a completely different standard, and it may be tackled by the SLSC program at some point, but we're having to set that aside at the moment. The specification sets some really detailed and clear requirements for bidders in a tender situation, including the units that we want their responses in. There's about 40 well-defined parameters for the luminaire. There's some suggestions about minimum reasonable warranty requirements, and we'll get onto the issue of supporting documentation. We're trying to actually minimize supporting documentation at the initial stage, and we'll discuss that in a few moments. We're also wanting to make sure that you have the key information you need to do proper life cycle costing, not just look at initial capital costs, because obviously LEDs, like any other light source, use energy and have maintenance needs. It's really important to take into account the total life cycle cost. And this document is designed to work hand in hand with the other model spec that we're going to be talking about next week. So very briefly, I'm going to talk about the model specification structure, and then we're going to get on to some of the key issues for consultation. The model specification is divided effectively into 7 parts. We're strongly encouraging users of this specification to lay out a clear process timetable for all participants. This has been something that hasn't necessarily been well handled in early LED tenders, and we think it can do a lot to help smooth out the process. We're also letting you know that there should be a clear project description. It's not enough just to specify the technical requirements. People need to understand what the project aims are, and a few basics, things like form factor, what general shape of luminaire you're wanting to use. We're trying not to be too prescriptive. We want performance-based outcomes, not highly prescriptive specifications to help people get the best from a tender situation, but there are some basic suggestions in there. We'll also include lighting design specifications. You need to define the geometry and lighting tasks that you want delivered, the standards you must comply with, the warranty requirements, and some basic tender assessment criteria. And all organizations will have different weightings for those criteria, but we've suggested a starting point list for you to look at. And the tender response is divided into 4 very clear schedules that people have to respond to under the LED luminaire, performance details, price information, supplier information, and warranty information. So we're going to focus now on 5 hot button issues to do with this specification that we think are going to be the issues that people most interested in the consultation stage. And we're going to explain those and then stop after each one and give you an opportunity to provide your questions and comments. The first item we're going to talk about is supporting documentation. This is a very, very active market at the moment. There are up to 80 parties trotting around New Zealand and Australia with public lighting offerings, LED public lighting offerings. So you should expect a large number of respondents, particularly if it's a larger tender. 30 to 50 has been typical in some tender situations. So you need to be a bit careful about what you ask for in terms of documentation. I've been involved in one tender recently where there were 7,300 pages of documentation submitted. And that, of course, creates an onus on the reviewers of that documentation, the technical reviewers and the evaluation committees, to look at that material and properly consider it. So be careful what you ask for. We know that people are asking for a great deal of documentation because of discomfort. They're not really comfortable yet buying LEDs. But we're suggesting a strategy in the model spec that allows you to minimize what you ask for, at least in the first stage. We have a list of supporting technical documentation, test reports, compliance certificates, design calculations that people have to attest to that they have completed and are available on short notice to provide. But we're not actually suggesting you ask for those every time you go out to tender. We're suggesting that it's done only at the shortlisting stage for your shortlisted candidates. And if you're uncomfortable about that, we've suggested an option of asking tenders to sign a statutory declaration. That places a really strong binding legal onus on them to only attest to having things that they really do, with very serious consequences if they don't. So we'd like to pause there and field a few questions, any comments people have about this particular consultation item. So if you could do that in chat, if you have a chat window open, if you could type in any questions, we'd be very happy to take them. Okay. So we have a question from Kuduz Wazirzada at RMS in New South Wales. He's asking, are the model specifications project specific? The model specification has a couple of options for you for different types of situation, most particularly the division between roadways and paths versus area lighting. But of course you will need to customize that for your particular installation. You have to specify whether you want P4 lighting or V3 lighting depending on the roadway, or a P2 lighting of a park pathway, and you'll have to specify something about the geometry, but there's a clear structure in which to do that in the model specification. I don't think we have any other questions or comments at this stage, so we might move on to the next consultation item. Next one I suspect may elicit a few more comments, and that's a very controversial issue of color temperature. We have different parties around the world deploying 2700 Kelvin, 3000 Kelvin, 4000, even 5000 still happening in some locations. The choice about color temperature has been a very controversial one. LEDs started at very high color temperatures, but it's now possible to deliver much warmer color temperatures, still with good color rendition and without a great loss of energy efficiency. There is no clear scientific or industry consensus yet about exactly the right way to do this, and it's a balancing act between public safety versus public and environmental health. Last year in June, the American Medical Association suggested that all LEDs should be 3000 Kelvin or less. That's a sort of warm white. And they did this really to minimize blue light content. Their concerns relate to like disability glare and discomfort glare. Circadian rhythm disruption can be caused with too much blue light. The human visual system is very sensitive to too much blue light. And there's also issues to do with road safety, particularly on the main roads at higher speeds. possible loss of visual acuity if the blue light content is very high. Now, the U.S. Department of Energy has come out subsequent to the AMA and noted that this is not a new issue, that sources that we use very commonly here in Australia, in particular mercury vapor, has a lot of blue light, as do metal halide and to some extent even high pressure sodium. So this is not something that's new because of LEDs. They don't magically have a new type of light in them that the other sources didn't, but they do have quite a bit of blue light and potentially a lot at high color temperatures. The second point the U.S. Department of Energy made is that they suggested that a reliance solely on color temperature to assess blue light content is potentially highly misleading, and that it was an oversimplification of the issue, that some 3,000 and 4,000 Kelvin LED streetlights have high blue light content, others have much lower, and you really need to look at a measure called spectral power distribution. And in the end, they and many people related to them have challenged several aspects of the AMA findings. So it's good to be aware of both sides of this debate, but the question is, what do you do in the interim? At the moment, we have no explicit guidance in the Australian standard. We have a recommendation in a related document, a technical specification, that suggests we use 4,000 Kelvin in Australia. And on balance, we suggest that councils and road authorities stick to 4,000 Kelvin on main roads, really because of the assessment by some U.S. researchers in particular that gives the best safety outcomes. And main roads are where the greatest risk of accident causing injury and death is. So it's mindful of that. We're suggesting that people, while this remains unclear, stick with 4,000. But we also need to be cognizant of the growing push for warmer color temperatures in other types of areas. And we're suggesting that you consider using 3,000 Kelvin in areas like residential roads and parks. And if you're following this debate internationally, you've seen stories even in the last week in places like the New York Times and Daily Telegraph talking about the controversy created by some rollouts at higher color temperature. Places like Rome, Hawaii, Montreal, New York, Chicago, many of them have been very controversial deployments. Some of them have stopped partway through even their tendering processes and revised their views and gone to warmer color temperatures. This debate has not been so public yet in Australia and New Zealand, but I think it's really important to be aware of it. We are overall, though, suggesting you stick with 4,000 for main roads and consider 3,000 for other areas. Now we'll just pause there again just to see if anybody has any comments or questions about that particular issue. So the first question we have is from Richard Wood and Scott Holland. I think they're at Brisbane City Council. And they have asked about what are the light levels in Australia with P4 and P5. So P4 and P5 are the type of lighting used on most residential roads in Australia. P5 is not used in New Zealand. They have slightly higher levels. P5 is amongst the lowest lighting levels in the developed world. It's broadly about twice bright moonlight, and as was discussed at the recent IPWEA conference in Brisbane, it's as little as 20% or even less in some cases of comparable standards in North America and Europe. So these are very low lighting levels, and of course the harmful effects of any type of radiation, including light, are based on dose. So we do need to be mindful that the issues that are arising overseas with much higher lighting levels aren't necessarily directly applicable in Australia because our lighting levels are generally much lower. Second question is from Kudus Wazirzada at the RMS again. He is asking about insects. There has been some suggestion that higher color temperatures attract more insects, and there's a very good entomological basis for that. Insects generally, about 80% of them, are attracted to blue light. and some, but not all, early LED installations in Australia with very high color temperatures, 5,000, even 6,000, did attract a lot of spiderweb buildup. And it's not proven yet in an independent study, but there is a very strong suggestion that warmer color temperatures, in particular as you get down towards 3,000 and possibly even 2,700, will attract less insects. Somewhat speculative at the moment, but there's certainly a good basis to suspect that there's something there because so many insects are attracted to blue light, and any light with high blue content will tend to attract them. We have another question from Bill Harnley at the City of Hobart. He's asked what are the existing color temperatures in Australia of main roads. It's a little bit of a mix at the moment. So most Australian main roads are high pressure sodium, which has a color temperature that's down in the 2000s, something like 2700 or even lower than that. Some remnant mercury vapor on main roads, but let's focus on high pressure sodium. The thinking at the moment is that there is actually a safety benefit in moving to 4,000 Kelvin light from LEDs on main roads, good high quality white light. So I have a question from David Crosley at the Lighting Council. He's asked, were any specifications outside of New Zealand and North America considered in drafting the document? To date, we're not aware of any precedent that particularly adds to the case, but this is a consultation stage. We are absolutely delighted to take suggestions. If, David, you have other suggestions we should look at, really happy to see that. So I think we might move on from there. Talk about the third issue, and that's to do with glare. This again relates to both disability glare, that's something that actually affects your ability to see, and discomfort glare, something that is uncomfortable to look at. LEDs are effectively point sources. They can have high levels of glare if the optics aren't well designed. There are certainly some reform efforts underway at the moment on the Australian Standards Committee to look at this, but currently the road lighting standard for residential roads and parks and area lighting, the thing that local governments deal with most often, has only very limited guidance on glare limits. It just sets one limit at one particular angle. So the model specification gives you some options about how to deal with this, and it's basically suggesting you seek some additional information, either in the form of luminous intensity tables and polar curves, which show you what the glare level is in different directions, but in particular we're suggesting a focus on the peak intensity at some of these high viewing angles, 70, 75, and 80, where the real glare issues are. It's not sufficient just to look at the glare levels at one particular angle. You need to look around all of those high angles of incidence. So again, we'll open up to any questions and comments. If anybody has any thoughts or any questions about the issue of glare and how we're dealing with it at the moment. We have a question from Brisbane City Council again about obtrusive light. Absolutely need to consider how we deal with obtrusive light. It's somewhat of a separate issue, but one of the great beauties of LEDs is because they're effectively point sources, they're far more controllable than the old massive HID lamps that we used to deal with. And so properly specifying the optic for your installation is very, very important with LEDs. If you don't, you might be very unhappy with the outcomes. In fact, one of the challenges with early LED deployments is they strictly followed the standards in the United States in particular and had very, very sharp cutoffs at the boundaries where the standards said they should have sharp cutoffs. And everybody looked at them and said, oh, that's absolutely appalling. You know, where's the spill light onto the building facades, or we want a soft edge to this light. Now that's largely been rectified, but you do need to be very, very careful about the particular optics you require. That's why it's so important when using this model specification to really define well the actual lighting task to be delivered. And in the model specification, there are options that you can consider for adding additional glare shields, either the front or the back of the luminaire, which has been very common in many overseas LED installations. If you take a light designed for a 20-meter road reserve and then suddenly put it on a narrow road, you're going to have trouble, and it's better to preemptively deal with that. Another comment with respect to obtrusive light, noting that Georgia Power in their procurement specifications include obtrusive light controls, and absolutely recognize that. We have got some comments in there, but if you think they need to be enhanced, we're more than willing to do that. Belinda Hill from Adelaide City Council asks about what consideration is being given to color rendering. We have suggested that there is a specific parameter in the draft. We're not particularly talking about it or focusing on it today, but it is in there in the draft model specification. We're going to be suggesting that at least 65 and most probably 70 is the minimum color rendering index that you should specify. Most manufacturers seem more than capable now of delivering at least 70. You can certainly specify dramatically higher color rendering to get very, very full color definition, but it's very unclear that there's much benefit to that in the public lighting context, whereas it may be very, very useful, for example, in a retail shopping environment. It's unclear really that there's a lot of benefit in going to very, very high color rendering. But it is in there in the model spec. We have made some suggestions, and of course you're always free to improve. There's a question from the RMS here in New South Wales about the aviation industry, and they have specified, sorry, just hang on. It's whether the aviation industry has specified any requirements for glare. Certainly there are requirements around airports and very tight controls of any light emitted above the horizontal. Now, the good thing about LEDs is that almost all of them are capable of zero upward waste light, so they should be capable of fully meeting the aviation requirements around airports. There are some with drop lenses. They're probably not quite so suitable, but most are full cutoff luminaires. And you can actually see around Sydney Airport, one of the first LED deployments to go in this country is on Airport Drive on the side of Sydney Airport. So more than capable of meeting those requirements. Okay, so we might move on to item number 4, light loss factors. So luminaire output decays, whether it's old style lamps or LEDs. Over time, the light output of all sources decays. Now with LEDs, fortunately, the decay in output is very, very slow over quite some number of years. That's why you don't need to change them in the way that you do the old lamps. But you do have to take it into account when assessing compliance. And the other aspect to light loss is the pollution buildup on the luminaire. And if we're honest about this as a society, we don't really know yet how LEDs will go over the medium to long term. They certainly don't have the high temperatures internally that traditional HID luminaires do, and so there's strong initial evidence from places like Los Angeles that there's dramatically lower levels of dirt buildup. But it hasn't yet made it into standards, including our standard. There is some subjective classification of low, medium, and high pollution areas under AS 1158, but I think it's fair to say that it's not widely applied and it's often misunderstood. And so we are going to put in as much guidance as we can with respect to light loss factors. We're taking some of that guidance from British standards, which have given a much clearer set of numbers for dirt depreciation. And we're likely to suggest 3 possible scenarios as default pollution scenarios to choose from when you go and use this model spec. It will be basically an inner suburban CBD area with relatively high levels of pollution. In particular here we're talking about things like diesel particulate that gets stuck on lenses, a suburban specification, and a regional and rural specification with very low levels of pollution. And we're going to suggest some specific numbers to use for each of those scenarios. So we'll pause again there, and happy to take any questions and comments on this issue of light loss and maintenance factors. We have a question from the RMS here in New South Wales about whether current compensation is used to keep the light output the same over the life of the luminaire. Yeah, essentially we over-design at the moment, and we have to factor in the decay both of the output of the luminaire and the buildup of pollution, and ensure that whenever we get to the next cleaning or lamp replacement cycle in the old luminaire parlance, that we're still complying. So there's some enormous opportunities here if we do this well, and particularly with smart controls, which I think Brian will be touching on next week, to not overlight, to keep things at the compliance level, but we still have to consider it, and that's really what this issue is about. Okay, we don't have any other questions at this stage, so we'll move on. No, sorry. There is a question from Adelaide City Council about, are self-cleaning luminaires rated within the spec? We have not specifically touched on the issue of claims about self-cleaning luminaires. There is fair to say, an ongoing debate about whether flat glass or drop bowls are better at staying clean over time. I don't think there's convincing evidence either way, and I don't really fully support the idea of self-cleaning luminaires being really supportable with solid in-the-field evidence. I think all luminaires in practice need cleaning and inspection. There may be some reason why drop bowls clean a little bit better or worse than flat glass, but I think the evidence is just not there yet, particularly in Australian context. That said, if you have comments you'd like to make on that particular issue during the consultation stage, we'd be delighted to receive them. So the final issue that we think is going to elicit a fair number of comments is regards to dimming control. And the power supplies in an LED are electronic devices, and there's effectively two choices that you have. One is to specify what's called 0 to 10 volt dimming, which is effectively an analog type of dimming based on a secondary circuit that goes between 0 and 10 volts. The second option is effectively a digital control, and it's called dolly, and it's not particularly widely used in public lighting. But we'll talk about that in a minute. There may be some reasons that you want to specify this. And the reason we think that you might want to focus on dimming control when you're specifying luminaires and think a little bit about your choice of power supplies is that it's more than just dimming that these power supplies enable. And I'd like to quickly give you an example of what is often referred to as trimming. There's various interpretations of the word trimming. It may be about optimizing start and stop times to really make sure that you don't turn the lights on too soon or turn them off too late. It sometimes is used to refer to ramping up or ramping down the lighting levels in response to ambient light levels as you turn them on and off. But the perhaps more interesting one is to do with reducing the initial lighting over the life of the asset. At the moment, HID is very lumpy. If you want to buy a light for a main roadway, you have a choice effectively of 150, 250, or 400 watt. And if you needed 161 watts equivalent, well, too bad. You've got to jump up to 250. So there's a great deal of lighting out on our roadways, particularly where there was existing pole structures and you couldn't optimize designs. There's a great deal of lighting out there that is effectively over-designed. And smart controls allow you to permanently dim down the level of lighting to the compliance level and not overlight for the duration of the life of that asset. Now, the second aspect that you may not have considered is about extending asset life. If you can take even a little bit of the hard work off the electronics, it has often a nonlinear effect on asset life. And so there's enormous benefits in trimming and dimming where you can, obviously maintaining compliance, but anything you can do to reduce the load on the electronics extends asset life. So that's certainly another reason to think about the introduction of controls, and in the first place, the power supplies that allow you to do that. The issue to do with dolly controls that I wanted to mention is that they're increasingly being seen as an effective asset management tool. And for people who were at the conference in Brisbane a couple weeks ago, you may have heard Georgia Power mention that they're using dolly as an inventory database asset management tool. They're effectively getting the 8 luminaire suppliers to that utility to pre-populate the luminaires with some basic information about the luminaire. There's a few blank fields in dolly, and they've put in codes referring to each manufacturer. They've put in information about manufacturing date, a variety of other parameters. Now what that means is when those smart controls are plugged in on the top of the luminaire, the asset register for Georgia Power is now automatically being populated with information about the luminaire, about the smart control. It's got a GPS chip in it, so it knows where it is, it knows when it was connected, it knows how much energy it's using. All of those things become possible, but it's a combination both of the smart controls and the use of dolly drivers with some of this information pre-populated by the manufacturers. This is not particularly a cost issue. The difference now between dolly drivers and 0 to 10 volt drivers is not really appreciable, but it certainly is a potential asset management benefit both for councils and road authorities as well as the DNSPs. And we've recently been provided with Georgia Power's approach, and we're looking at it in detail to see if it's a possible option for Australia and New Zealand. And I suspect we may be including a bit more information at the public release of the model specification. So the New South Wales RMS asks about whether the DNSPs will be able to compensate councils and road authorities for dimming or variable loads. It's a very good question. It's come up quite a number of times, both through the Lighting Council and in the context of this IPWEA program. Even if they wanted to at the moment, there is no clear mechanism under the national electricity market, in particular under the metering requirements managed by IEMO, to allow those benefits of dimming and trimming and anything else you might want to do with a variable load to flow through to the customer. At the moment, they simply take your inventory, multiply it by the rated consumption of the luminaire, and generate your bill from that. Now there's certainly lots of interest in doing this. There's some precedents in California and the UK where they've tried to tackle this, and I suspect there's more to come. At the moment though, the answer is no. Now that of course doesn't apply if this is a metered circuit. If a council, for example, has a meter in a park, you'll get the full benefits of dimming. If we're talking about roadways, the lights that are on the public lighting asset inventory of the utilities, it's not possible at the moment to get the financial benefit of it. It's a question about LED flicker and whether it might be worse with or without smart controls. There's certainly some LEDs that have suffered from flicker. I'm not aware of any problems that have been exacerbated by smart controls, but part of the reason for this model specification is to help filter out the lower quality products that may suffer from poor electrical design and therefore suffer from flicker. We have minimum requirements with respect to that and things like electromagnetic spectrum emissions that we have to meet, and not all products do internationally. We want to help customers without even having to think about it very much filter out some of the bottom end of the market. And flicker is certainly one of those things that is probably more associated with the bottom end of the market. Okay, I think we're probably done with the questions on that particular topic. Very quickly want to talk about the next steps. Thanks to the support of the Commonwealth Government, this model specification is going to be made freely available to all stakeholders via the SLSC website from late May. The precedent is there from the United States and Canada where they've done something similar. It's helped drive very high uptake of the model specification by making it freely available to all parties. And the IPWEA is going to evaluate the demand for training and webinars or face-to-face workshops. Once this is released, that's certainly a possibility if there's a strong desire for it. Now, model specifications are living documents and they need periodic updates. One of the advantages of doing this is that it can move quite quickly, but it's essential that you participate to help improve the documentation. If the kinds of questions you've been asking today have not been adequately answered, then you need to stick up your hand and say, I think you need to do something more in this area or that area. And momentum will only come through adoption by users, but obviously the more involved people are, the more likely it is to be successfully taken up. So finally, just a few thank yous. First of all, obviously we want to thank the Department of Environment and Energy who have sponsored this along with the Council and TAG. They have contributed the funds required to help deliver this draft specification. I want to thank my colleagues at Strategic Lighting Partners, Godfrey Bridger and Brian King, who've helped enormously with this. And I just want to make a final couple of comments. The IPWEA is doing this to advance the market for the benefit of all stakeholders. We're doing this because we have seen very strong success from similar processes overseas, and we think there'll be real benefit for it in Australia. Ultimately, as I said in the beginning, it's about bringing confidence to all players, knowing that you can robustly tender for LEDs and do so knowing that the key technical and other requirements have been covered. The consultation, as I mentioned, with the council, SLSC council members and the TAG members is happening during the month of April. And as I said earlier, the release will happen publicly in May. Anybody who's participated today, if you provided us with your details, you will be on the distribution list. So thank you very much. Please do send me any further comments, questions, concerns. Very much looking forward to interacting with you on this draft as we get it out the door over the next 8 weeks. Thank you very much.